Okay, first of all, thank you so much. It's for me a pleasure to be here. It was a very long trip, but we are here, and this is my first time in the GTEDs. So I'm going to share a knowledge with you in 20 minutes. I hope this will be enough time. We are WLAN streaming data pipeline, and I think this tool it will be a good tool to keep the Google things. It's black. Okay. I think this tool it will be keeping the the topic of the Google Cloud because we are going to use a Google Cloud to deploy the pipeline. So that will be awesome with the before talk. So okay, first of all, about me, my experience has been mostly with the startups from my country with evaluation with more than 200 millions of dollars. I have led teams there. I belong to a venture capital group. I'm not rich. I don't have millions of dollars to invest. I only support the startups in the portfolio to giving some advisory of the technologies or in the stack or what will be a good pitch or that or things like that. I'm one of the organizers for the PyCon Colombia conference. You are very welcome there, of course. And I'm one of the leaders of the Python community there in Colombia. We are more than 5,000 members there. Okay, before to start with the live demo, you have to understand some a little things about the Apache Beam. One of them is created by Google. Google call it like a unified programming model. It's quite simple. Why to use it? First of all, this is a technology that is not that is a cloud agnostic, so that means that it not depends of any cloud provider. You can run this ETL in every host provider or in a lot of runners that Beam support. It supports the most used language today, that is Python, Java, or Golang. It's open source, that is the best part, of course. There are two basic components that you need to understand today. There are more concepts, of course, in the documentation, but for today, to keep the things simple, you just need to understand those things. First of those is the P collections. This sounds like a complex or a straightforward term, but not. It's just your data set, right? It's just a JSON array with the objects. That is a P collection. It's just that. The other term is the P transform. It's just the Python code that you need to apply over those records. That is the P transform. You can see some examples. There is a CSV file. It could be our P collections. And you can see a simple function that is splitting and parsing the rows between the CSV. Okay, so Beam support and overriding of package. This is only a few of them. There are a lot of more packages that Beam support, like Mongo, Cassandra, Kafka, RabbitMQ. But this is one of the most used today. Some source, and since it could be BigQuery as a data warehouse, it could be a SQL connector. Any of the SQL connectors are supported. For example, in MySQL, PostgreSQL, all of them are supported. You can use as a queue message. Apache Kafka is also supported. RabbitMQ is also supported. There are another bunch of tools that are supported. You can use as a runner. Today we are going to use the Dataflow runner, that is the cloud native runner. We are going to talk a little bit why I took the decision to use Dataflow, because it's auto-scale. We are going to see this in a moment. But you can use Spark as a runner or Flink as a runner. This is the this is why this technology is cloud agnostic, because you can have your own host, and you can install Spark and use as a runner for this ETL. So Beam supports the streaming ETL, which is mean a real-time ETL. You can run a machine without any limit of time, so just receiving the payloads between a queue. This is what it means, what is real-time ETL, right? And Beam supports also the batch processing. That is the typical case that you have a CSV or a log, and you need to process once. Okay, talking a little bit about the architecture. So first, this is a serverless auto-scalable architecture. So we are going to use Google PubSub as a queue. Google PubSub could support more than 10 millions of requests per minute. If you compare with Kafka or RabbitMQ, of course, you can support all of those amount of records or millions of records per minute, but you need some extra effort. You need an DevOps effort to scale to support that amount of data, and Google manage this for you, right? So we are going to use Dataflow. It's the same because it's auto-scalable, because it's managed by Google. You don't need to be aware of the DevOps or the configuration or the Kubernetes cluster. You don't need to be aware of any of them. Dataflow can auto-scale automatically. It depends how much overload do you have in the runners. So, you know, scaling an Spark or Flink runner is so painful. Believe me, it's so painful. You can use Kubernetes and it's so painful. It's still so painful to scale. And we are going to use BigQuery. So Priyanka already mentioned what is the benefits of BigQuery. So it's auto-scalable, it's managed by Google. You have all of the resource of Google behind the scenes in BigQuery. So, and the most interesting part of the BigQuery is they only billing for the resource that you are spending for the query and not billing for the data itself that you are going to store there. And of course, if you use a SQL database like, I don't know, a Redshift in AWS, I don't know, I don't like this database because when you need to scale, you need to goes down the machines, reconfigure it again, and it made me feel like in the 90s. I don't know why. So this is a common diagram. You have a source that it could be a database, it could be a CSV, it could be a queue. And if you see, you can see the steps there. We have a P collection, a P transport. The P transport, the output of the P transport is a P collection. You have another transport to apply then, and you have the output, another P collection, right? And finally, is stored in a data warehouse or in a bucket in SD3, in a data lake, or in a data warehouse. And this is how it looks, the architecture in Google Cloud specifically. So you have, I don't know, you have a phone, a tablet, a computer that is sending the payloads through the queue. In the real cases, maybe you can have some authentication system before the queue if you want to authenticate the request, of course, to avoid that something attacks your queue sending trash. So we have in the middle data flow, and we have BigQuery as a data warehouse. So this is the architecture in the Google Cloud for this kind of ETL. Okay, what we are going to do in the demo is so quite simple. In the left, we have the original payload, and in the right, we have the transformed payload. Basically, we are going to use a third-party package. I'm going to show you that you can write a simple Python code, and you can use third-party package here without any problem in Beam. So we are going to use package to try to find where is the user agent. If you see the green lines, we have a large string of the user agent, and we are going to use a library to find what is the browser, what is the device, or what is the operating system, because this could be helpful for our business to understand what is the customer front. And we have the yellow line that is a remote IP. So yes, we are going to seek what is the continent, what is the country. Of course, this will be helpful, of course, to know our customers. We are going from what country, right? And we have the phone number that we are going to apply some transformation, just a standard transformation. What is the country code and what is the national number? Okay, before to go to the demo, there are some performance tips and errors that I saw in a lot of companies with this kind of ETLs. One of the most common is, one time I saw a company doing this in a ETL, doing a request to the external resource, to the API. The engineer arguing me that, hey man, but the request only takes 5 milliseconds. Okay, 5 milliseconds by 100 times, but 1 million times. If you have a real-time ETL, how many times is it, right? So this could block your ETL if you have, of course, a lot of requests per second, right? So avoid these kind of things. Another thing that I saw is this kind of validations against the database. Of course, this is an external resource, and this could block the database. And if the database is blocked, so of course your pipeline is going to block, right? So please avoid making requests to external resource. Only keep the logic that you need in the code to transform the payload. You can use external packets, third-party packets, but don't use external resource that it depends on the network, right? Because that's happened. Okay, so I already deploy all the resources because it takes some time. Okay, here we have Google Cloud PubSub resource already created. This takes some time, so I deploy everything that I need for this demo because the data flow takes some minutes to be ready to receive a message. But this is the Cloud PubSub. The name of the Cloud PubSub is Demo GTEX Global topic. This is the data flow already deployed, and we have here the BigQuery console. So let me show you the code before. Okay, we have an ETL with only more than 100 lines. To apply those transformations is very simple. If you are going to use Spark or PySpark, this could take more lines and is more complex. But you can see here that the functions to apply the transformation is just a simple Python code. It's no more than that. So let me explain a little bit of this ETL. So you have here all the configuration of in those lines. You can see some strings that are describing every step. One is read from PubSub. Another one is the code, the message, because PubSub is storing the message encoded in a base 64 format. We can see another string is parse the phone number. Another step is locate the IP address. Another step is get the user agent from the string that we have. And you are going to see these strings in the data dashboard that is describing here. And here, so you can see that is a simple function. The parse number is a simple function of Python. There is anything overlooked there. You can see that you can use a class like in any other regular Python code. The only dependency is that you need to declare a function that is called process. This is the main function that Beam is going to take into a class. But you can see here that I can call the nested functions in a class like this, right? Okay, this is the configuration for the pipeline. You just need to declare what is the project, what is the region that you are going to deploy the runner. You need to declare what is the bucket to store the temporal files that Beam needs. I'm declaring here that this is an streaming pipeline. This is the option that you need to declare. You need to say here that is a data flow runner. Okay. I need some energy here, please, before this laptop is going to turn off. So, and you see here what is the service account. And that's it. You just need only, oh my God, this is turning off. Help me, please. I need energy. Man, I think that you already connect that. Technical issues, man. I have to restart this machine, so give me some seconds, please. Sorry. Yes, yes. Give me some seconds. Okay, come back. Okay, it's time for the demo, but it's not showing the. Okay, come back to the demo. So here you can see in the data flow dashboard that You can see here the strings that we put in the code that describes every stage. This is so helpful for you because you can do click over every stage and you can have some metrics here. For example, what is the delay that every stage has, so you can see what is the problem. If you have maybe a delay in your pipeline, if you have broken something in your pipeline, you can see what is the stage that is taking more time than the other ones. So you see the metrics, this is the first step that is reading from the queue, and you can see what is the concurrency of the queue that is taking from reading, what is the delay that is saying that is 2 seconds only is the delay. And we are going to do a test sending, I know, maybe I'm going to send 100 message here. So I write a simple code, which is wrote with the Faker library. If you know, the Faker library is only to simulate some data. I'm going to say this through the queue, right, to simulate what is a client. You can see here is a dictionary with the name, with the company, with the phone number, with all of the needed in the data. So let's run this and send the data. Okay, we are sending the payloads, right? Okay, you see here the metric is changing because we are reading the message here. We are going to see how this looks in BigQuery. So we have already 200 records, so already processed 100 records in, I don't know, in 2 or 3 seconds, of course, and there is only a machine with only 1 core app, so it's really fast. And to end the demo, so you can explore the data using Data Studio. This is so helpful if you have a startup, so you don't need the odds guy for this, you don't need a big data guy for this. Everything is built in Google. For example, we can add a graphic, a country graphic here. And you can see here, I have how many clients I have for every country in the map, all automatically, right? You can see we can add another graphic, a pie graphic, for example, with the operating system of everyone. I don't know. Let me here. Okay, we can choose what is the device, for example. And we have the PC, we have the generic smartphone, we have the iPhone here, the iPad here. So you can see this is a very straightforward way to build a pipeline. To be clear, I'm not saying that big data is easy. Of course, there are another pipelines that are more complex than this one, right? But I think that if you are building a startup and need to take decision with data, because I encourage startups to be data-driven companies, right? You don't need to take decisions in what you do think or what do you like, right? I think that this is a quite straightforward method. You can build a pipeline in only, I don't know, in 1 week with a full stack developer. You can build some graphics like this, and this is very helpful to know what is your client, what is your customer, what is the behavior of your clients, and this could help you to take decisions. So that's it for today. If you have any questions, I'm going to work around here in the stage. Thank you so much.
Are there any questions for our speaker today? I think there's an agreement, no demos on stage, because we had 3 demos and there was kind of a hiccup in every one of them.
Something goes wrong in the demos, oh my God.
All right, I think that's it. Thank you very much.